Good evening and welcome to what will be our first lecture of the 25 programme, and also to give advice on what the future programme looks like throughout the year through our various comms. I'd like to just say a quick thank you to MBDA for their continual support and sponsorship and for hosting tonight. And what I'd like to also do now is introduce our speaker, who is Alistair Hodgson, who's going to give us an insight into probably some other stories you haven't heard. Heard lots of stories about the Comet, but he's probably going to give you an insight into other things which aren't so probably much public domain. So without further ado, I'd like to hand you over to the capable hands of Alistair, who will actually take you through this fascinating presentation. Thank you.
Okay. Thank you very much. Good to see you. Let's get one thing straight before you. See before you a man who is at the very edge of his comfort zone. I've worked at the Havilland Aircraft Museum for about 19 years, volunteer. My specialisation really is post-war jets and aircraft of the Royal Navy, post-war military jets rather, and aircraft of the Royal Navy. So the Comet is somewhat on the edge for me, I'm afraid. It's very easy to tell the difference between me and somebody who knows a lot about the de Havilland Comet, but I'll do my best. I'll tell you what the origins of this talk were. I did a talk last autumn at the Fleet Air Museum, to the Friends of the Fleet Air Museum down in Overton. And I've been there before, and we were discussing what we might do as a lecture subject. And I said, well, how about the Comet? Because it was 75 years ago last year that the Comet first flew. So we agreed that would be a good idea. I'd done a presentation on the Comet for its 70th anniversary, but that was to a very lay audience. Now, no way is the Fleet Air Museum a lay audience of people who don't know about aircraft, and neither are you either. So I had to dig deep, and I've had to dig deep again for tonight. But in the course of doing it, this is a bit like sort of presenting my homework, really. Here's what I found out about the Comet. And in the course of doing it, I thought, yeah, we all know about the Comet. You know, it was the world's first jet airliner, and it was great until it crashed. And then it wasn't. The reason it crashed was because it had square windows, and that was it. And then it was a failure after that. None of the above is true, apart from the bit that it was the first jet airliner in the world. All the rest needs another look at, really. So basically, ladies and gents, this is what I found, and I hope you're interested. I hope you enjoy it. The origins of the Comet were rather surprising. And the biggest problem is actually getting this to move. Why is this not doing anything at all? Oh dear. Right. There we are. Let's go back. And let's just go into slideshow again and go from the beginning. Come on. Hey ho. Right. Let's try again. How about that? Yay! Right. Oh, well, that's the first technical problem gone. Okay, let's look at the origins of why was it that Britain decided to build a jet airliner? Why us? And what we hope to get out of it? Well, the roots of the de Havilland Comet are rather surprising, because you can actually trace it all the way back to the Moscow Conference during the Second World War, when Winston Churchill went across to Moscow to talk with Stalin and with Averell Harriman, who was there to represent Franklin Roosevelt. And what's significant about this for the Comet story is not so much what they talked about at the conference, but the route that Winston Churchill had to take to get there. Because obviously he was in London and he had to get over to Moscow, which is pretty simple, basically. You get in an airplane at London, you fly across to Moscow. Well, not in the middle of World War II, you don't, because it involves flying over northern Germany, Poland, and lots of occupied Baltic states. So it's really not a terribly good idea, especially if you're the Prime Minister of the UK. So he couldn't do that, so he had to take a rather more circuitous route, instead of which he flew from London down to Gibraltar, flew all the way along from Gibraltar to Cairo, stopped off at Cairo and sacked General Wavell for not doing a terribly good job in North Africa. So, I mean, you've got to make the most of your journey, haven't you, really? So that's what he did there. Went on from Cairo up to Tehran, refueling stop in Tehran, and ultimately flew on to Moscow. And, of course, the reverse journey all the way back again via an identical route. So it was a hell of a long way to get from London to Moscow. Not only that, but you know, he wasn't in the first flush of youth by this stage. He was well into his late 60s, maybe early 70s, I don't know. He had to have a medical before he actually undertook such a long flight. But he was doing it on a rather primitive form of transport. He was doing it on his own personal converted B-24 Liberator called the Commando. Now, all right, it would have been well fitted out with comfy seats and probably a bed and no doubt a plentiful supply of whiskey and so forth. So, I mean, it was okay as far as it went. But even so, you know, that sort of journey length on an aircraft like that was a pretty rough order, really. And it is said that when he landed, he said, we've got to do something about this because this cannot be the future of air transport after this war is over. It really can't. And he caught something of the sentiment among a lot of people in the aircraft industry too, who'd started to realise much the same thing. There was a little article in Flight magazine in December 1942. I'll read it for you. It said, the whole British Empire at the present time has an operational fleet of transport aircraft comprising conversions, makeshifts and cast-offs, totally inadequate to represent the Empire in serving the air routes of the world in the peace to come. Have we to rely on other nations to do it for us? The British aircraft industry is equal to the task. The government should decide this vital question at once. And thus spake Flight magazine in December 1942. So people were on the case as well as Winston was. So we reacted in the way that all good British governments do. We formed a committee under Lord Brabazon, John Moore Brabazon, who was an old friend and colleague of Churchill's as well. And his brief was to look at what we had to do to get back into the civil aviation market once the war was over. So he formed his committee and the committee deliberated and they came up to two conclusions, basically, that they would need, first of all, adaptations of existing aircraft. There were 4 aircraft that were suitable for adapting in the short term to get us through the initial problem. And longer term, there would need to be 5 new design types, 5 new specific roles for aircraft, civil aircraft post-war that needed to be designed and manufactured by the industry. So the adaptations were the Avro York, which came from the Avro Lancaster, the Handley Page Hermes out of the Halifax, the Avro Tudor from the Avro Lincoln, and the Short Sandringham, which was developed from the Short Sunderland flying boat. Now, those 4 were adapted. They all came into service. Basically, that's what got us through the Berlin airlift in the late 1940s. You think about it, they were the mainstay of the British contribution to the Berlin airlift. So far, so good. That got us through the immediate problem post-war. But it didn't end there because it couldn't end there. There's an awful lot more to do. So the 5 new designs that were developed by the committee and were issued as specifications to the industry, and eventually all 5 of them saw the light of day as prototypes and 4 of them actually went into service. The large transatlantic airliner became the Bristol Brabazon. That was the only one of the 4 that didn't go beyond the development stage, but it did actually fly, never got very much further. A short-haul feeder airliner, which was the Airspeed Ambassador eventually. Medium-range airliner for Empire routes. Notice the word empire is coming a lot here. Remember, this is back in the days when we'd still just about had an empire. So the thinking in the government was, how do we service the empire? How do we link the empire by air? Medium airliner for Empire routes was the Bristol Britannia. High-speed transatlantic mail plane. Here we introduced the Comet. This was what the Comet was to be. This is the job it was due to do. And the small feeder airliner was the de Havilland Dove. Now, just a point worth noting here that Airspeed was owned by de Havilland. So de Havilland got 3 of the contracts and Bristol got the other 2. So de Havilland 3, Bristol 2, rest of the industry, thanks for turning up. That was not a bad score, actually, on the whole. Let's look at the design. Let's see what the design was. Okay, this is a memo that goes all the way back to the 1940s. It's 1944, this one. You won't be able to read it, and I'll be able to get a few bits for you here. It's a very high-speed transport aircraft is offered with a limited number of passengers in reasonable standards of comfort, not very much. And it plays to the strengths of the aircraft but without exploiting too many of its weaknesses. Paragraph 2 goes on to say that it's actually going to be a development of the de Havilland Vampire with 3 jet engines instead of 2. It's going to be a twin boom aircraft, basically, and this is a memo going to the senior management of de Havilland. This is how it developed. Back in 1944, the time of that memo, that is actually what they were envisaging: a twin boom aircraft with 3 jet engines, not as big as the Comet as we know it, but a little bit bigger than the Vampire. 1945, they'd gone away from twin booms and they were looking at a canard aircraft there, slightly bigger, but still a bit unconventional. Then we went to a tailless design with a 45-degree wing sweep in 1946. And the final thing that they pretty much settled on by 1947 was still the 45-degree wing sweep, but with a tail on it as well. But there was a memo written in 1946, and this was written by R.W. Clarkson, who was the chief aerodynamicist of the company, and he wrote it to 2 of the directors, Geoffrey de Havilland and C.C. Walker, and also to Mr. R. Bishop, Dick Bishop, who was the designer of the Comet, the chief designer. And the gist of this email, just of this memo was, listen, chaps, we're missing a trick here, because if we're wedded to this idea of a 45-degree wing sweep with or without a tail, it's not as good as it could be, because if we reduce that wing sweep from 45 to 20 degrees and make it a lot more conventional, we could carry 4,000 pounds more cargo with a fuel saving of about 7.5% on the effective mileage per gallon, really, as compared to the 45-degree wing sweep. We'd have a slightly less efficiency at altitude, but we'd have better takeoff and landing speeds, and all way round it would be a winner. And Mr. Clarkson attached to his memo these 2 sketches at the back you see on the right there. The bottom one is what they were considering for the de Havilland 106, and the top one is what he was suggesting: let's get away from this 45-degree wing sweep and be a little bit more conventional. And that, of course, on the top, this top sketch is a Comet. Essentially, that's what he came up with. And so that was actually what was adopted. They reviewed his proposals, they looked at his calculations, and they said, yes, that is pretty much what we're going to do. And that is how design type for the Comet, the de Havilland 106 Comet, emerged. Fairly conventional form, 4 engines in the wing roots, conventional tail and rudder, and there's our Comet. The sort of things they were looking at to inform the design, again, we're back to this empire question. It had to fly existing empire routes, so it had to fly the routes to places like Canada, South Africa, India, the Far East Asia, Australia, but it had to fit in with the existing empire routes and the existing air traffic. So there was no point designing something that had a landing speed 50% greater than everything else, because it wouldn't fit into the air traffic control pattern coming into these airports. It had to basically be able to take its place in the queue with conventional piston engine airlines. So it had to need low landing speeds, low approach speeds, and so forth. It needed, they didn't want, or they didn't assume that any airport would want to extend their runways simply to accommodate a jet airliner. And in that they were wrong, because as it turned out, airports around the world were queuing up to extend their runways to accommodate jet airliners, because they could see it as the future. But when the first initial stages of the Comet, they thought no. So it needed to have good short performance, good takeoff and landing performance, and everything else. So we had the low wing sweep. It had quite a low wing loading eventually, and that gave it very good low speed performance, and it enabled it to land at the smaller airports, which they thought was important at the time, and indeed it was, but it became crucial later on in the Comet's career, because it enabled later operators like British European Airways and Dan Air and people like that to fly Comets in and out of smaller airports around Europe where they might not otherwise have been able to get in. As another little knock-on effect, it kind of benefited the Nimrod too. Now, you don't design an airliner to loiter. Anyway, it's the last thing you want to do, isn't it? But the Nimrod, of course, as a maritime patrol aircraft, needed to loiter. And with the Comet design and that Comet wing platform, we found it could do it. It could actually shut down 2 engines and loiter over the sea on an extended patrol time. And it was all down to that early wing design. So let's have a look what we actually get inside now. Let's have a look at the pointy end first of all. Here we are. up the flight deck, and right hand, you can see there on the right hand view, it's pretty much like a Lancaster bomber in actual fact. You know, you've got a pilot and you've got a flight engineer and you've got a radio operator and a navigator and everything else. All you need is a bomb aimer really, and you're away. You know, you've got pretty much the same sort of thing. But there we are. It's very conventional wartime technology for crewing up the thing. On the right hand side, behind the pilots, behind the flight deck, you have a galley where meals were prepared, not warmed up, not just reheated, but actually prepared. And on the left hand side, you've got something rather akin. It's a luggage and baggage area, freight area. It's something rather akin to a guard's van in actual fact, because there was not a great deal of luggage capacity under the belly of the aircraft. Quite a lot of it was taken up by avionics or by fuel. So that was the front end of it. The middle part, here we are. Here is the passenger accommodation. 28 seats in the whole thing. That's all there was. That's all the seats for the fare-paying passengers. You can see them there, 7 rows of 4. And the 8 seats up the front, you might just see it says smoking accommodation. That was where you could sort of decamp to during the flight to have a cigar and light your pipe, smoke your pipe, and read your magazine, so forth. It's possible that they were used for meals as well. Here we are. Here it's all laid out for a nice dining experience. That is not a gun on the table, by the way. It's the question I always get asked, is that why is there a pistol on the edge of the table? It's not, actually. I've zoomed into that, and it's a pillbox. It's one of these little ornamental pillboxes with something sitting in front of it, possibly one of these things for lighting a gas burner and a plate heater or something like that. Not a gun. Okay, so there we go. Here we are. Here's our passenger accommodation. So we've got 28 seats. We've got a seat pitch of 45 inches in the Comet. That's rather nice. Here we go. Here's 45 inches. There we are. That's 45 inches. EasyJet Airbus, 29 inches. There we go. 29 for an Airbus, 45 for Comet. Just leave that thought with you. Just saying. Okay. So it's rather nice, actually. You've got like room to spread out and everything else. And if you fancy having a fag or a ciggy or something and smoking your cigar, you've got somewhere else in the aeroplane to go and do it. It's all rather nice, actually, isn't it? So there we are. We've got the fine dining experience, which you can have. I don't know if they ever actually did very much of that, but it was available if you wanted to. And the other thing I'd like to draw your attention with, you look towards the rear of the aircraft, is the rather elaborate provision of toilets too, because it's rather nice there as well. You don't just have a couple of lavies at the back like you do normally on an Airbus thing these days. You've got a ladies' powder room, and you've got a gentleman's washroom and things like that. So the ladies and gents have their separate facilities. It's all very nice. The ladies have got somewhere to sit down afterwards and adjust their makeup and their hairdo and everything else. And it's all rather civilized in actual fact. But look at that. I mean, look where you start actually making use of the aeroplane. The little arrow pointer doesn't come up, but here we go. You know, at that point in the aircraft, you're starting to make money. All of this is overheads, basically. You think of an Airbus 320 or something like that. Where's the first row of seats? About there, isn't it? Okay. So that's what they did, because they did, you know, they were in competition with not other airlines or other airliners or anything. They were in competition with Cunard and people like that, and Queen Mary and Queen Elizabeth. So that's what you got to do. A few of the technical design features we have. We talked about the 20 degrees wing sweep. Engines in the wing roots. It was a bit of a tricky thing for maintenance, but one of the advantages was if you lost an engine in flight, you don't get a lot of asymmetry in the flight. Okay, so you don't need a whopping great rudder on the thing, or a tailplane or a tail or anything. You can get away with a slightly smaller tail on that, because you're not going to lose a lot of control in that point. The first prototype had single wheel undercarriage for the main undercarriage. The production models had bogie landing gear. They were one of the first aircraft to have that. And fully powered controls and full cabin pressurization, both of which are going to play a very big important point in the later part of the story. But they were very, very innovative at the time. So it went into production. It made its maiden flight on the 27th of July 1949, which so happened to be Geoffrey de Havilland's 67th birthday. And it was also the 32nd birthday of the chap that was at the controls, who was John Cunningham, Cat's-Eyes Cunningham, chief test pilot, very successful night fighter pilot in the war. Shared his birthday with the boss man, and they'd had quite a day of it actually on that day, on the 27th, because they'd had a press day over at Hatfield, and they'd invited all the press down and everything else to look over it. They might have done a taxi run or something like that. They didn't fly it, and all the press got packed off on the train back to London and everything else, and the place was clear, and the only people left at Hatfield really was a couple of photographers, and all the production people. All the people from the factories were still hanging around too, because it had been quite a big day. And they decided, Cunningham and the bosses and de Havilland themselves decided, well, it's a nice evening. It's still, the weather conditions are good. The aircraft is signed off. It's flyable. Why don't we just do this? And so they did. And so they made their first maiden flight in the evening of the 27th. And Cunningham took it up for about half an hour, something like that, took it around, evaluated some of the initial flight envelope. It was all very good. He finished off by coming back to Hatfield and doing a 100-foot pass over the runway, just for the benefit of the workforce who were all out there to clap and cheer and see this aircraft that they created. The press were furious because they didn't get to see it. The whole thing was done in somewhat undercover, but there we go. They got their share later on. Into service we go. 1952 it entered service and it got its certificate of airworthiness. January the 22nd, 1952, 73 years ago yesterday, in actual fact, and it was signed off. Comets were starting to be delivered from Hatfield to BOAC, and the first pure jet flight was made London to Johannesburg on May the 2nd. Actually, in my first company, I worked with a guy who was on that flight. I worked for the firm that made boilers and equipment for power stations. And old Ken was he was one of the test engineers, and he travelled the world. And his greatest claim to fame in the company was that he'd been on that inaugural Comet flight to Johannesburg. And everybody, oh yeah, Ken, you were on that first flight. What was it like? What was it like flying the Comet? Don't know, not bothered. Ken was a steam railway enthusiast. He couldn't give a monkeys about what aeroplane he was flying on. Not interested. What a shame, eh? There we go. So anyway, entered service. London to Tokyo service inaugurated fairly soon afterwards. Cut the flying time in half between London and Tokyo compared to a piston engine airliner. This is what's starting to grab the attention now of the media and the travelling public. Obviously, we're going to get to a bit royal interest here, royal patronage. Duke of Edinburgh was always very interested in technology developments. He was a frequent visitor to Hatfield anyway. Came along in 1952 before the thing entered service for an official visit. Here he is on the flight deck with John Cunningham on the left, and on the right he's there with Geoffrey de Havilland and Mr. Bishop, who was the chief designer. So very, very impressed he was as well. They had a special, just after it entered service, they had a special event now for the Queen Mother and for Princess Margaret. When they brought them over to Hatfield, they put them in a Comet, and they took off, and they had a tour of Europe. They didn't actually land anywhere in Europe. It was just Hatfield to Hatfield, but off they went, and they had a couple of hours flying around over the Alps and everything else, nice meal and everything else. And of course, the royals were all suitably, duly impressed. Little bit of Hollywood glamour as well, because as we all know, Geoffrey's first cousin on his dad's side was Olivia de Havilland, and the Hollywood screen actress. And she used to come over when she could, when filming allowed, to visit cousin Geoffrey over in Britain. And she used to come over to Hatfield and tour the factory and chat to the workers and everything else, build a bit of Hollywood glamour there. And Olivia actually had a pilot's license. So one of the features of her coming over to visit cousin Geoffrey was that they'd take an aircraft for a spin at some point during the stay. Probably not a Comet, but my money would be on a Dragon Rapide or something like that. But she used to come over, she used to fly, and the people loved her because she could talk flying to the people at the factory too. Great. It goes into service. Nobody's ever seen the like of the Comet. People are just desperate. They just come to the airport to see it. You know, this is a big airplane that has no propellers on it. Wow, how cool is that? All the way around the world, wherever it landed, the crews were feted, the pilots were feted, the passengers were treated like royalty. It was just amazing. De Havilland started to look at riding the crest of this wave. They started looking at setting up two new factories, one up in Cheshire, one up in Chester, and one over in Belfast, just to make Comet airliners. It was going so well. And then all of a sudden it wasn't, and things started to go wrong. There were 3 incidents, crashes, first of all. The first one, only about 5 months after they entered service. One Comet taking off from Rome, damaged beyond repair. Nobody hurt, but the aircraft was a write-off. What basically happened on the investigation? The pilot pulled up the nose too high on takeoff, and he entered a stall. He got the thing into a deep stall. Too much drag on the aircraft. Tail surface is ineffective. Could not get any higher. Eventually realised he was fighting a lost cause. Shut down. Ran off the end of the runway. aircraft written off, everybody got off okay, but obviously it's a bit of a problem. March 53, the Canadian Pacific Airline had bought several Comets to inaugurate a Trans-Pacific service, and one of them was on a ferry flight out from UK over to the Far East somewhere, Indonesia, somewhere like that, or ultimately Australia, to begin this service. It was full of kit to inaugurate the service, and a few extra people too, so it was rather overloaded. Again, the pilot lifted the nose too high on takeoff. Remember, a lot of these pilots would have been bomber pilots from the Second World War. They would have been used to flying 4-engine piston airliners, where you've got full whopping great propellers on the wings, which as you push the throttles up, they're blasting air over the wings at a hell of a rate. So your control surfaces, your flaps, are extremely effective for takeoff and so forth. And a jet aircraft, obviously the airflow rate over the flaps and so forth is only as fast as the aircraft is going forward. But these captains weren't always appreciating that. Also, remember what we said about the powered controls. There was no feedback whatsoever in the controls. You pull the stick back, you're basically operating a switch. You have no feedback at all. There was no stick shaker to tell you if you were approaching a stall. There might be a stall warning light, but that was your lot. You had no physical feedback through the controls. No wonder it was going wrong. This particular one, again, ran out of runway, and it came off the end of the runway. At the end of the runway at Karachi was a great big drainage canal. Big wide drainage canal with concrete walls on either side, and the thing went into the drainage canal and it piled into the concrete wall on the opposite side, and that was it. Burst into flames and everybody sadly killed. Another one in May 1953. This one, I believe, was the anniversary. It was actually the first anniversary of the Comet's entering service, and taking off from Calcutta Airport, Dum Dum Airport in Calcutta, and flew into a thunderstorm and broke up. And air crash investigation at that point wasn't sufficiently advanced whether they could analyse the wreckage and spot what had actually gone wrong with it. All they knew was that it had broken up in the thunderstorm, either because of the updrafts and downdrafts in the thunderstorm, possibly by the pilot overcorrecting, or perhaps that aircraft was critically overstressed by what we're going to encounter next. And it had an existing problem, and the thunderstorm was just the straw that broke the camel's back. Anyway, Comets were investigated. The fleet was grounded a little while. They did their best to sort of get over the PR crisis and everything else, restored faith in the Comet, and everybody was happy again. Comet started flying. It was all great until the two famous crashes, known as the Rome crashes, in 1954. January 54, ALYP from British BOAC took off successfully from Rome near to Elba Island, and it broke up at about 30,000 feet, something like that. In April, exactly the same thing happened again. A BOAC Comet leased over to South African Airways, and it crashed near the Stromboli volcano island. 35 and 21 people killed. Wreckage landed in the Mediterranean. Hard to get it back. Comet's grounded at this point. There is obviously something very, very seriously wrong. They were lucky with ALYP. They managed to locate the wreckage, and they got the Royal Navy involved, and they managed to dredge up quite a bit of the wreckage from the floor of the Mediterranean, brought it back to Farnborough, pieced it back together again. And it was the first time that an air crash had been scientifically, forensically investigated in that way, by piecing back the wreckage and trying to reassemble the aircraft and see what has happened. In parallel to that, an awful lot of work was going on. One airframe, ANAV, was allowed to fly still, and it was covered in strain gauges, and it was flown in a very careful manner to detect how the aircraft was moving and flexing during the course of flight and pressurization. Two more airframes were brought over to Farnborough, a British one and a French one. They were brought over for the purpose of being stress tested in a specially built water tank, where it was stripped of all the internal fittings, just down to a bare fuselage, filled with water on the inside, filled with water on the outside, and then pressurized cyclically to simulate the stresses of flight. The wings were jacked and so on and so forth. The British one, ALYU, was first put into the test tank. That's it in there now. The French one, BGNX, was brought back from Paris airport by John Cunningham, who flew it back at a height of 2,000 feet because he did not dare fly it any higher. just in case anything happened to it. So he crept it in over to Farnborough, crept it down, and that was it. It was stripped down, dismantled, never flew again, and it was the second one ready to go into the test tank. It was cycled in the test tank through about 3,000 flights, 3,000 dummy flights of repeated pressurization, repeated cycling and so forth before any form of structural failure occurred. And these were the findings. Now, we have to go a little bit back to the initial design of the thing. When the Comet was designed and initially built in the late 90s, just after the war, they put a lot of emphasis, and this was the government attitude too, on static testing. That's what they thought the most important thing would be. And the thing that everybody was looking for was the pressure difference in the fuselage at altitude between the inside and the outside of the fuselage. P, making it big red P there, okay? Because this is the biggest envelope that has ever been pressurized before. So clearly this is the most critical thing. If the aircraft's flying at its design height of 40,000 feet, pressure is about 8.25 psi. There it is in kilopascals for our younger viewers who may not know psi to know. But anyway, 8.25 psi, and that was the pressure which was designed for. Now, the proof test regulations, the regulations said that the proof test had to be 1 1/3 times that pressure. And the proof test is where you test the aircraft and it has to withstand that pressure, the application of that pressure, and it has to not suffer any structural deformity after that. It has to be completely clean bill of health. And then the ultimate design strength of double that pressure, 2p, these were the rules, these were the test rules laid down, whereby it still had to withstand, it still had to be structurally sound, but some measure of deformation was permissible, but the thing had to retain its structural integrity. That's what they were required to do. De Havilland said, no, we're going to do one better here. We're going to go further than that because we're so confident in what we're doing here. So they went to a proof test of 2p, twice the pressure differential, 16.5 psi, just over an atmosphere, and they tested to an ultimate strength of 2.5 times that pressure difference. And they also did 2,000 cycles of repeated stress to just over P and a bit, okay, just to prove that it could withstand the cycling stress. 1953, some new rules came in. The government introduced some new regulations for stress testing, that it had to be stress tested again until a fuselage failed, and they tested it from 0 to P, to the actual design pressure, and it had to withstand that for a minimum number of cycles. De Havilland did the test again, and they got it up to 16,000 cycles between 0 pressure differential and the operating pressure, 16,000 times before they get any sort of failure, which so happened to be at the corner of a window, which is kind of is and is not relevant in a way. We'll come to that in a minute. They weren't worried because the design life of the Comet was only 10,000 cycles. It does beg the question of why they found themselves satisfied with 3,000 cycles when they did the previous test. And I think probably the reason is they justified it because when they did the previous test, they were testing to over the pressure differential. So this time they're only testing up to the pressure, the required pressure. So they said, well, it does 16,000, so it's pretty okay. So they were happy, but it's a big but. The fuselage section they used for this new test in 1953 was the same section that they had used for the earlier pressure testings when they were doing the design. Okay? The metal had altered its structure. The metal had cold worked. It had undergone a process called work hardening. Aluminium alloy will do that. It makes the crystal structure a little bit different, and it makes the metal slightly brittle. And as a result, although the metal is brittle and it will fail catastrophically, the fatigue resistance is very slightly greater. So they got away with it, basically. But the upshot was that 16,000 cycle fatigue test didn't mean a thing because it was not representative. It was not done on a representative production Comet fuselage. If they'd taken a Comet off the production line, brand new, unflown, untested, and subjected it to the same test cycle, it would probably have failed very quickly, and they would have known that they got a problem on their hands. But because they did it the other way with the old, they took the old one back in and tested it, didn't mean a thing. Obviously, there's going to be an inquiry. There was a big accident inquiry, which was published in 1955 by the Ministry of Transport on the 2 accidents. Findings were no great surprises here. It was structural failure of the pressure cabin brought about by fatigue, cracking of the material. The factors were the thickness of the outer skin of the fuselage. The thickness of the outer skin was the thickness of a credit card. It was 1 millimeter thick. It was far too thin. They made it thin because they were looking to save weight, because de Havilland insisted that although other engines were available by this stage, they insisted on using ghost engines, the de Havilland Ghost engine. And it was heavy, had a low power to weight ratio, and as a result, the Comet was slightly underpowered. They needed to save weight wherever they possibly could. One of the ways in which they chose to save it was in the structural strength of the fuselage. The cyclic stress due to repeated pressurization is what we've seen. It wasn't up to that. And also the stress concentration around the fuselage openings. Now here's where the bit about the square windows come in. Yes, the windows were square. Yes, the window frames were square, but it wasn't the only square openings in the aircraft, because along the top of the fuselage, the top of the cabin, were other openings for radio aerials and things like that. There were hatch access for radio aerials. They too were square. And when they got to the wreckage of YP up off the floor of the Med, they found that the part that failed was not a window. It was one of the hatches over the flight deck, which housed a radio aerial. And that was where the corner had cracked and caused the catastrophic failure. When they tested the sample aircraft in the water tank, it went at a window. When they did the earliest stress test, it had gone at a window. But the fact was that generally the openings are square, not specifically the windows. They also found microscopic cracks around the rivet holes where the window frames were riveted in. Now, there is a story, I've not been able to verify it, that originally the window frames were to have been bonded into the fuselage structure, not riveted. But when the Comet first was made, it was the winter of 1947 to 48 when they were looking at this, and that was one of the coldest winters on record in the UK. And the conditions inside the factory workshops were so cold that they couldn't get the Redux bonding compound to properly cure and form the joint, form the seal. So the production people asked the design office for a concession to use riveting as well as or instead of the Redux bonding. And because those windows were riveted, tiny cracks emerged. Some of them were detected, some of them were repaired, as we'll see later on. Further findings, de Havilland were criticised for the way in which they stress tested the window frames. What they tended to do, they built a section of the fuselage, put a window frame in it, put a nice window frame in it, and then they build a metal box around that, and they would pressurize that and stress test that. Now, in no way is that representative of a row of windows in a 90-foot long aircraft fuselage. So it wasn't representative. The way they did it was not representative of what the aircraft was actually going through, either in the thing that they tested or in the way that they tested it. They looked at the way in which the cracks were detected and manufactured and the way they were dealt with by drilling out little holes and everything else. They said, well, you know, given the knowledge, that's okay. That's pretty much all right. Going back to that redox, there was a man called Dr. Jablonski who said, I think half the problem is that the redux bonding is all wrong. And you know, it's reacting to the fact that the cockpit, the cabin is warm inside and the outside air temperature is minus 60 degrees C. So that's having an effect. And that was tested and that was disproved. So it wasn't the redux bonding. It wasn't the problem. There's an interesting paragraph in that report. There it is. I'll let you read it. Basically saying they didn't realise that fatigue resistance was going to be such a problem. They just didn't know. They designed it to the best of their knowledge. They just didn't know. So that was the report. There were elements of that report that Geoffrey de Havilland could have kept as a commercial confidential, but he chose not to. He said, no, this is about flight safety. We have got to let everybody know. And that's how, of course, Boeing were looking over the shoulder of McDonnell Douglas and people like that in the States. And that's how the American airline industry got straight in with airliners like the 707 that had round windows from the get-go. And the rest is history, of course. But the Comet recovered. The Comet actually got through this, and this is the part of the story people often don't realise. The next developments that they rebuilt, they had a few on the blocks being built for Comets, being built for Canadian Air Force. And they were built with stronger fuselages, and they came into service with the Royal Air Force. The Canadians didn't want them, but the Royal Air Force took them. The Comet 2s were rebuilt, stronger fuselages, better fuselage. Rolls-Royce Avon engines now, lighter and more powerful. They only make 18 Comets built. No airlines wanted them at all, unfortunately, but the RAF took them. And interestingly, some of them, a lot of them were transports, but 2 or 3 of them were converted into Cold War spy planes. They were jammed full of electronics and avionics and intelligence gathering equipment, and they were given to 51 Squadron, which specialised in this sort of thing. And they flew a lot of covert Comet 2 missions all the way around East Germany, everything else, just for elite gathering and things like that. One of their 3 aircraft they lost in a hangar fire. And there's at Witten, I think, and there's an urban myth about this. Because these aircraft were so secret, they were under armed guard 24/7 by the RAF police. And one of the Comets was in the hangar. Somebody had left a bit of electrical kit on, which overheated. The thing caught fire. The hangar caught fire. The aircraft was on fire inside the hangar. Fire brigade turned out, and the RAF police said, "You're not getting in there, mate. Sorry, it's under guard. Sorry, not doing it." They said, "But it's on fire." "Yeah, but you're not coming in because you've not got the clearance." "Yeah, sorry." So they just sat there and watched it burn. Whether that is true or not, I don't know, but that's the myth. That's the story. Anyways, they got another one out, the transport group, and they converted it, stuffed it full of the electronics, and that survived, XK695. And that was the only one of the spy planes that actually survived. It went to Duxford. It was scrapped in the 90s because it was corroded far too far. It couldn't be saved. But the front end of it is actually over in the Havilland Museum at London Conians. I've heard rumours it's going to become the Gate Guardian at the museum. So there we go. Comet 3, there was only one of those completed. 2 were built, only 1 was completed. And it was used as a bit of a test bed, really. But it was the first jet to cross the Pacific. John Cunningham flew it all the way around the world, and they gave him the Harmon Trophy afterwards, which is a very nice accolade for aviation people who've achieved something particular. And he won it there in 1955. And it kind of put the Comet back on the map. People realised, yeah, this aircraft is still around. It's come through the fire, rather. And the Comet 4 was the definitive version, basically. Rolls-Royce Avon engines, more fuel, better passenger capacity, more comfort and everything else. Broke long-distance records, went into service. It was the first jet to fly across the Atlantic, and it started breaking records for flights all the way around the world. And yes, the Comet was back. It was here to stay. There's a stat for you. 2 years, 19 Comets flew 27 million miles. So it wasn't a rubbish aeroplane by any manner of means. It was very, very successful, very good at what it did eventually. Airlines around the world did queue up to buy it eventually. It went into service with all sorts of different people all the way around the world, and with the Royal Air Force over here as well. We've got to say something about the Nimrod, really. I don't dwell on it because it's not a Hatfield aeroplane. The story really surrounds Hatfield, so forth. The first 2 were built at Hatfield. They were converted Comets, but the rest of them were all done by Avro or the works up at Woodford, Hawkstedley, up at Woodford. So it wasn't really a de Havilland baby, a Hatfield baby at all. And here we come back to that wing. Remember, it had this rather good wing that would enabled really good low-speed performance. Well, they found that they could make a Nimrod fly on 2 engines, and it could loiter over a target, over a patrol area out in the Atlantic or something for ages and ages. And it was all down to the original soundness of that original design. So, you know, another little spin-off that came right in the end. So what can we sort of get out and conclude from all this? Well, it was a pioneering aircraft. There's absolutely no doubt about that. Something I've discovered in the course of researching all this, it was probably the last plane that was designed around the requirements of the British Empire. You know, we needed to get to the colonies in Canada, dominions in Canada and Australia, New Zealand and South Africa and, you know, India just about before it partitioned and everything else. But in its wartime roots and its late wartime roots, it's something we need for the British Empire, you know. The industry has agreed that it was as good as it could be at the time, and any reason in which it fell short was simply due to a lack of general technical knowledge. It was the first person that walks into a minefield is the most likely person to get blown up by the mine. The Comet was the first in the field. The American industry said afterwards, Boeing said afterwards, they said if we had been the first people to design and put in production a jet airliner, we would have built it with square windows too. It's just that they didn't know the problem. They didn't understand the technology, the engineering of pressurizing such a large envelope and what you had to do. The crashes in the Med were not per se due to the square windows. Okay, the inquiry didn't actually criticise or make observations regarding the window shape. It was just something that dropped out of the obvious process, that this was all part of the problem. De Havilland got over it. De Havilland made a very major contribution to passenger air transport, and they continued to do so through the 50s and through the 60s. With jet transport, with the de Havilland 125, one of the first executive jets in the world, the Trident, the first aircraft that could auto land in conditions of poor weather, everything else, and ultimately, of course, the British Aerospace, the BAE 146, the Whisper jet. So they carried on. They learned the lessons, and they built on the success. They understood the failures, and the tragedy that was the crashes, the Rome crashes, particular. Something good came out of it, because it led us into the field of air accident investigation and made it the very forensic, exacting science that it is today. It's all because they had that need to do it for the Comet. So there's always some good comes out of it somehow. And that's it. But there's something about a Comet, isn't there? You know what? You don't hear people getting up on their hind legs and making presentations about Boeing 707s, do you? And if there's any 707 enthusiasts in the audience, I'm very sorry. I hope I haven't hurt your feelings. But you know what? People still love comets, because there's still a few of them around, and people still go and they see them. They go, oh, wow, look at that. Isn't that fantastic? The last one ever to fly was an RAE one, Canopus XS235, and it lives at Bruntingthorpe these days. It used to be taxiable. I don't believe it is these days, because I think they've pretty much got rid of the runway at Bruntingthorpe, filled it full of motor cars or something like that. But it's there. It's all kitted out. It's got seats inside it, and it's got the full flight. It's all otherwise manageable. Still got the engines. It was the scene of the very brief beginning of my very, very short television career, actually, because about 6 or 7 years ago, the BBC did a programme called Great British Inventions, which various celebrities championed the Great British Invention, and they went and interviewed people and so forth. And a very nice actor chap called David Harewood was chosen as the champion of the jet engine. And he talked to Rolls-Royce at Derby, and then he came and sat on the Comet, and he talked to me, and he talked to a couple of others too about it and about why the Comet was so good. I was the curator of the de Havilland Museum at the time. That's how I got the gig. So we sat in the passenger compartment, and we talked and we chatted about how wonderful the Comet was and everything else. Tell you what, Alistair, why don't we go and have a look on the flight deck? Good idea, David. Let's go and do that. So we both went up the rope and went into the flight deck. And I went to the captain's seat, and he went to the P2 seat and everything else. We're both fairly tall, and we both simultaneously hit our head on the overhead panel. And there's a little bit of a cutout in the BBC, if you see it on iPlayer or something, where they had to cut out about 5 seconds of the dialogue because it wasn't suitable for broadcast before 9 p.m. Because we just did. Anyway, it was great. It was great. It was good fun. So the French Comet that was going to go into the test tank at Farnborough for all those tests that John Cunningham flew back, never went, because they learned everything they needed to learn from the one that they put in beforehand. So the French Comet kicked around at Farnborough for many, many years. It was eventually stripped down. They took the wings off, the tail off, everything else, stripped it all out inside. They wrapped it in the plastic to protect it, so forth. And eventually they got so fed up with it, they gave it to the de Havilland Aircraft Museum, and it came over. And there's the kind of state it was in, really, for many, many years, until a team of volunteers stripped off the outer cocoon plastic, got all the rubbish out the inside, and were left with just basically an empty metal tube with nothing much in it. But they worked long and hard for many, many years, and they put not a whole interior, but half an interior. And they took the very inspired decision that one half of is set out as passenger accommodation, that it would be seen, and the other half is an exhibition, and that's what you can see today. The seat covering is completely wrong. It bothers me. I don't think it bothers anybody else, but the pattern on the seats is wrong. But there we go. That's just me. But there we go. It's rather nice to look inside. They've made an absolutely cracking job of the flight deck. It really is gorgeous. It's very, very nice. All the seats have been recovered. All the instruments have been replaced. Everything is there. They've even got the right sort of chart on the navigator's table. Everything. It really is beautiful. The galley just behind there on the left, there's the galley where the meals would be cooked, and not just heated up, but actually cooked by the steward. And there's the ladies' loo on the other side. That's the ladies' powder room, where the ladies would adjust the makeup and so forth. They've got a little seat and a little table and a little mirror to do it all for themselves. and it's all rather nice. It's a bygone era. The aircraft itself stood outside for many, many years, but it was the mainstay of our campaign with the Heritage Lottery Fund to build a brand new hangar, because the hook we hung that campaign on was, if we build a new hangar, we have a lovely new hangar, we can put our Comet back into the hangar, because that Comet is the last one remaining that has the square windows. The nice people at the lottery gave us the money, and we brought the aircraft back inside. So the aircraft is now on display indoors. It will never go outside ever again, and you can walk in through it, you can walk through it, see everything else, and it's all rather gorgeous. Remember the one that was instrumented with the strain gauges and everything else? Another one just at the tests, ANAV. And that one was eventually scrapped, but the nose of it was saved, and the nose went to the Science Museum, where it was fitted out with a few seats and bits and instruments and control columns and throttles and what have you, and the kids could go in and they could play with it, and they could say, oh look Mum, I'm flying the aeroplane, everything else. I was one of those children. I imagine possibly one or two of you were too. If you went to the Science Museum any time in the, I don't know, the 60s, 70s, 80s, there was the Comet, and you could crawl in it as well. Eventually the Science Museum got fed up with it, so they offered it to the de Havilland Aircraft Museum, who, as they do, accepted it because it just said de Havilland on the label, so that was enough. And there it is. And it is in the process of being turned back to what the Science Museum did with it. Just put some instruments, put some seats in it, and let the kids go in, and Mum can take the selfie. Hey, look, Mum, I'm flying the aeroplane. Nothing wrong with that. It's going to be nice, but at least we're saving it. At least we're keeping it too. Now, here's a nice one. Here's an interesting one. This is a Comet 4, front end of a Comet 4. I believe the story was that it flew with Dan Air for many years, and it was serviced down at the Dan Air base at Lasham in Hampshire. And eventually it passed on to the ANAE, wasn't it, Boscombe Down, and was flown with Boscombe Down. It may possibly have been the other way around. I can't honestly remember. But either road up, it was serviced and looked after by one of the techies down there, whose name was Mike Pymont, and he was very fond of comets and very enthusiastic about comets. And he did say when he ultimately retired, I think he retired from Boscombe, and he said to them, if you're ever going to scrap that one, let me know and give me first refusal, because I'd quite like to get a bit of it to turn it into a flight simulator. And eventually he got a phone call. He said, we're scrapping this thing next Tuesday. How much do you want off the front? And so on the phone call, he had to think about how many feet he wanted sawn off the front of the aeroplane. He said, I'll give us 20 or something like that. So he got the front 20 feet of a Comet, which he took back to his house in the West Country, and had a nice large garden shed in which he installed the nose of a Comet 4, and he progressively turned it into a flight simulator, and that's what it is to this day. It all works. It's brilliant. You can go in, you can fire it up, the screens come alive with the full surround screens. The only thing it doesn't do is it's not on hydraulic jacks or anything, so it doesn't actually move as you move the controls. But boy, it's realistic all the same. I couldn't resist putting this one in, actually. Here's his nibs here. Yours truly actually having a go at it. Do you know what? When you start it up and you push the throttles and you pull the stick back, you can feel the seat pressing into your back. It's not, but you just feel it. It's so realistic. It's just amazing. People are so fond of comets that they build their own still these days. There's a guy over in America. He's on here tonight. Hello, Steve, if you're listening. I hope you're well. He's building his own Comet. He's an airline pilot. He runs a software company for flight simulation. When he ever gets 5 minutes to himself, he's building a full-sized front-end nose of a Comet to convert into a simulator. He's already done a Vulcan. Look it up on YouTube. It's unbelievable. But here we are. He's building his own Comet. And here he is. He's building the whole thing. And it's exactly a replica of what's going to... And he's going to do the full flight sim when he's finished with it too. It is going to be unbelievable. The Comet still has that sort of hold over people, 70 years on, because of its shape, because of its history, because of what it did. People still love comets, and I think that's just great. Look at how it progressed. Oops. There we are. Look at how it progressed. It grew, it stretched, it became more powerful, it got more passengers. It went from a little thing that was really designed to compete with the shipping lines, with Cunard and people like that, and it progressed up to being a fully fledged airliner that formed the mainstay of people like British European Airways, Dan Air and so forth. It was the mainstay of their jet fleet. It's just an amazing story, and I found it amazing to really find out about it. I couldn't have done this without a lot of help from a lot of people around the world who are into this thing. There's Mike, there's Guy, and there's Steve there. Mike is the guy with the simulator. Guy is a very clever guy who does some simulations, and he's a photographer, and he does graphic design, and he's done virtual reality. He's done all the graphics that you see, the title of this, of comets. And Steve is the guy who's building the one over in a hangar over in Milwaukee. Just amazing. Thank you, gentlemen, for all the help you've given to that. And thank you to you for sharing this journey, sharing my findings. That's what I found out. That's my homework on the Comet. I've enjoyed greatly finding out about it, and I've enjoyed greatly to present it to you, and I hope you've enjoyed it too. So thank you very much indeed. Thank you.